Hello, we're WhereWild, and we're super excited to be able to present our final project today in a video form.
Hi, I'm Drayden.
So I'm Lucas.
Hi, I'm Luke.
Hi, I'm Kelly.
So to start out, we can just give a high-level overview of what WhereWild even is. So WhereWild is an automatically generated field guide for over 400,000 species that's available in your pocket or on the web. And how we create WhereWild is we essentially take observational data and combine it with environmental data, where observational data is a set of data points of when and where a species has been observed, such as this cactus example we see here on the left. And we combine that with environmental data, which is how high is it at this location, how much precipitation does it get in an average year, how hot or cold it is, and all sorts of other environmental and climate related variables. By combining those both together, we can sort of reconstruct which habitat and climate a species prefers and use that to populate our field guide. So what can WhereWild do? WhereWild can give you a super easily understandable description for any of the species we have. It can give you in-depth analytics on how a species relates to its environment, so you can use it to find outliers or other interesting things. And you can also search and sort for any type of species and by any environmental variable. So you can do pretty much whatever you want if you're looking to do analysis on how species relate to the environment they occur in. The local heat map is essentially highlighting areas near you where there's lots of active species right now. And what I mean by right now, I literally mean that based on the current and recent weather, we update this heat map to reflect that. It's also going to give you recommendations for what specific species are active in the area and why, and many of these reasons will tie back to what the recent weather actually was. Let's say we specifically care about plants, so we can click on plants, it's going to update this heat map section, and it'll also give us only recommendations for plants on the sidebar. If we zoom in, we can get recommendations for what might be more active right now, maybe more of a micro level. We can scroll down for a bit until we find a species that interests us, maybe like this one, click on it and go to the species page. So now we're on the species page, and this is the place where you can get an in-depth analysis on a specific species. The first thing to notice here is this description. This description is automatically generated, meaning we have one for the over 400,000 species in our database. And it's a really easy way to, at a glance, understand how the species relates to its environment without needing any technical knowledge. So we can see here that if we were on a hike and maybe wanted to find it, we can see that we might want to look in shrublands or other sparsely vegetated areas. And we might want to look in sort of mountainous, cold desert areas is what we can glean from this description.
The next major section of our species page is our environmental features section, which is essentially a more in-depth look into this species as it relates to certain environmental factors. We have several environmental factors related to bioclimatic data like temperature and precipitation, Earth's surface such as land cover, recent weather, and terrain like slope aspect and elevation. This essentially lets the user get a more in-depth look into what environments this species prefers. Now, this can be pretty overwhelming and kind of hard to understand for users. It can be hard for them to compare it to other similar species, which is why we have this relative ranking system, which will essentially inform the users how this species compares on a certain environmental factor to all species in its genus, all species in its family, or even all species in its kingdom. And we can see what percentile it would fall into on the mid, mean, or max. So you can compare this species to all plants or all cactuses. Now, this relates to our observation map down here, which is a map of all the observations on iNaturalist of this specific species. We can also filter this by country. This only appears in the United States, so that is the only one in the country filter for this location. By state, sorted by number of observations, and even by county. It will update the environmental feature section to only have the values for the observations in the filtered location, and it will update the observation map to also only have the observations in the filtered location. If we go back up to all countries, if we wanted to look for specific outliers in this set, we could highlight, say, the minimum temperature to look for the coldest annual mean temperature observations. And if we zoom in, we can see it's highlighted those observations in red, so users can see the exact observations that grow in the coldest places. In addition, if a user wanted to see how a specific observation compares to the species as a whole, they can click on that observation and highlight it in the environmental features. This will turn the dot yellow to highlight it, and it will show a marker on every single environmental factor so that the user can see how it compares to the species as a whole. Finally, let's say a user in, say, Reno, Nevada, wanted to see if their backyard could support this species, but there's no observation. Well, they can highlight a specific location that doesn't even have an observation in the environmental features, and it will still show a marker for how that location would compare to the species as a whole, which will allow the user to tell if their backyard could support this species.
Here is a demo of our search and filter feature. Our search and filter support textual queries. For example, I want to find all cactuses observed in Utah, so I search for cactus and apply the location filter for Utah, United States. I can also increase the number of results. We not only support textual queries, but also allow sorting results via an environment variable. For example, I can sort within the cacti taxon and sort them by annual precipitation, so I can observe which cacti tolerate the most rain. Once again, I can narrow the filter and sort to just Utah. I can still use textual queries in the sorting mode. A use case of this is finding which plants can survive in your backyard. One way to do this is to select your county, then only allow results with more than 50 samples. These results would likely survive in your backyard.
So one limitation of WhereWild is that it does rely on crowdsourced data. So this may be more biased in favor of areas that have more population. There also may be kind of spotty observation data for species that are not as commonly seen. So for this reason, we have actually implemented the ability for users to upload their own sets of observation data. So this is really useful for actual scientists or people who have access to that kind of data. So we'll just navigate to this upload page here. And then there's two steps to this. So first, you upload the data set. I have here just locations of a real species formatted as a CSV file. You upload it, and then it generates a zip that is returned to the user right here as processed observations. And then step two, you take this processed zip file that I have here, and then what it does is it returns a page very similar to a real species page. This is just using the data that we've provided via that CSV. So this allows a lot more flexibility and versatility if you do have access to your own actual observation data. So you can see the observation map is here with all the same functionality, as well as the same environmental features section with all of the same variables here.
For our tech stack, we use Python scripts to pre-process our data, which is then uploaded to a Backblaze B2 database. Our backend runs on Docker and then uses Fast API to serve the data to the front end, which is built using React Native and then deployed on Android, iOS, and web. We used an agile-ish development using our GitLab issue boards. On our backend, we closed 73 issues with about 31,000 lines of code, which about 9,000 of which were tests. On the front end, we had 196 issues closed, around 53,000 lines of code, and a good chunk of that was also tests.
So putting it all together, we have successfully built an app that runs on both web and mobile. It's very performant and has a really wide feature set. It's a lot of power to this app. There's a lot of nuance to the functionality to it. It's a very unique idea that does something that's really never been done before, and something that's very innovative in the field of wildlife data analysis and just educating people about the outdoors. Additionally, we have it deployed. It's available for free at wherewild.net, and we're planning to continue working on it after the end of this semester. So lastly, we just want to acknowledge the people that have helped us along the way. First and foremost, we want to give a huge shout out to our advisors. The professors that helped us throughout the last 2 semesters were Aaron Wood and David Bean. And then additionally, we want to give a big thanks to the TAs that helped advise us, Ian McBride and Kute Ikin. And then lastly, we just want to shout out the data sources that are publicly available, and our project couldn't have been done without them. Most notably GBIF and all of the crowdsourced observation data that we took from iNaturalist. But then there's just a huge list of the public data sources where we got the environmental data, and that is available on the acknowledgements page on our website. So that is it for WhereWild. Thank you so much for watching, and we're really excited about this.